The BritChips podcast is proudly sponsored by Silicon Catalyst UK. Hello, I'm Anthony Miller and welcome to the BritChips podcast, where I have conversations with movers and shakers in the UK semiconductor startup scene. I met my next guest at a cohort graduation event organised by Future Worlds. Now, Future Worlds is the tech accelerator at my alma mater, the University of Southampton, though, dare I say, it didn't exist back when I was an undergraduate over 50 years ago, would you believe? Now, my guest startup is called Deep Fabrication, and it's at the picks and shovels end of the semiconductor industry, in other words, tools of the trade. And they're developing AI models that analyze chip designs to predict likely defects prior to fabrication. And you can only imagine the benefit that could have on reducing the time, the effort, and the cost in the semiconductor manufacturing process. But while Deep Fabrication is my guest day job, you may be surprised to learn that he also has a lucrative side hustle in the build-to-rent property market, as well as being an advisor to one of the few, perhaps the only quantum computing startup listed on the London Stock Exchange. He is Dr. Yasir Noori. Yasir, welcome to the BritChips podcast.
Thanks very much, Anthony. Thanks for having me.
It's a great pleasure. Now, look, Yasin, we clearly have so much to talk about, so maybe we should start at the very beginning, because your involvement in the deep tech industry actually started with quantum computing rather than chip fabrication. So can you tell us a bit about that?
Yeah, so after I finished with my undergraduate studies at the University of Dundee in Scotland, I joined a PhD research project at the University of Lancaster. And at that time, my supervisor, Robert Young, he was starting a spin-out company called Quantum Base. Quantum Base is interested in quantum security applications, and I was interested in quantum key distribution at the time as a PhD student. So using quantum communications, quantum technologies to secure communication between senders and receivers, and that's the backbone of our, that replaced the backbone of our communications, which is currently classical communications, classical cryptography. And yeah, since then I've been doing quantum technology since between 2013 and 2018, and then I moved to semiconductors, rather classical semiconductors afterwards. But all of these are under the umbrella of semiconductors, which has always been my passion.
Yeah, because in fact, as I alluded to in your introduction, Quantum Base then went on and actually listed on the London Stock Exchange, didn't it?
Yes, actually, it was one of the biggest milestones. They were listed on the London Stock Exchange in 2025, so that was last year, March. So if you're interested, find it in the London Stock Exchange.
Well, that's fantastic. Are you still involved with it at all in any capacity?
I'm basically still keeping my equity, of course, but I'm just as an advisory, sometimes small collaborations here and there. But I'm very close connections and very close friendships with my PhD supervisor and the co-founders.
Well, that's great, and onwards and upwards. And as we were discussing when first we spoke, I hope to be able to chat with Robert at a future podcast. But let's see. But clearly, quantum computing was not the career you actually wanted to follow. What prompted that? I don't know. Was it a change of mind, or what was the dream you wanted to follow then?
Yeah, so after leaving Lancaster, I joined Southampton as a research fellow. I was doing classical memory devices, so digital memories, and then I worked on 2D materials as a sort of materials for optoelectronic devices. So I've always, on the back of my hand, I've had the sort of passion for starting a startup. I noticed that quantum technologies are a bit too earlier stage than I wish, and I thought also the fact that we have such a fantastic capability here at Southampton in terms of semiconductors fabrication, that's what led me to deep fabrication and using deep learning tools for semiconductor fabrication.
In fact, is that what attracted you to Southampton in the first place, the fact that it was so well established in semiconductors?
Yes, Southampton is well known in the UK, and I would say throughout the world, that it has one of the largest and most advanced academic clean rooms, fabrication facilities for a research institute. It's one of the largest in Europe, I would say. That has always been a very interesting direction to go. And then since that's why I went from Lancaster to Southampton, and it's the best decision I've ever made.
Well, that's good. I mean, that fabrication facility, is that the one they call Cornerstone?
Cornerstone is a service provider, so it's a company within the University of Southampton that provides
Right.
services, fabrication services to external companies like startups or SMEs, small and medium enterprises within the UK. So, but it's utilizing the fabrication facility within the University of Southampton. The fabrication facility is called the Zeppler Institute Semiconductor Fabrication Facility.
And that's in Southampton as well?
That's basically in Southampton, and Cornerstone is using that facility to provide services to external companies.
Oh, that's great. And now, you did mention that, you always wanted to create a startup. But as I alluded to in my introduction, you do have a sort of another sideline business in build to rent. How did that come about, and how does that kind of fit in with your ambitions with Deep Fabrication?
So I think it was a way to obtain financial security. I knew that if I was to start a startup, it's a very risky adventure. I could be without a salary for years. So I needed to find a way to not only top up my academic salary at the time when I was an academic. I'm still an academic, but top up my academic salary, which is not up to my ambition, but also to find a way to establish financial freedom. So if one day I become without a salary, then I could still live on an investment. So I've started buying property, saving. First I have to save a lot of money, and then from saving, I was able to buy one flat, and then another flat, and then a house, and so on. So I've always been interested in working with my hand, obviously, and buying a sort of rundown place, or maybe a dated property, and because I thought I could do quantum technologies, I could do semiconductors. I should be able to refurbish a flat by myself.
So you're handy with the paintbrush, are you? Yeah.
Exactly. I shouldn't be a problem. If I could work in a clean room, I could be able to do plastering. I should be able to do small brickwork. So yeah, it's a very good business model, I would say. It works especially in the UK. You buy a property and you refurbish it, and then you refinance it. You pull your money out that you've put in the property, and then you rent it out, and then you use that to buy another property, and you also refurbish and refinance and repeat, and so on. And then with a number of properties, I realized this is not my thing. I mean, I have enough properties to live, to make a living and replace my salary, but it's not the deep tech that I'm passionate about.
So it's really a sort of financial enabler, because I'm getting the feeling that your heart and soul is in semiconductors and deep fabrication. So
Yeah.
are you kind of just letting the buy-to-let thing run itself now, so you can devote your efforts on into deep fabrication?
Yeah, absolutely. So once you finish with the property, you could let it rent it out, and then leave it, hand the key to an estate agent, and then leave it. So it was mainly just to provide financial security for me and my family, so that I know that I could take something very, very risky without having to worry about not putting food on the table.
Well, that's good to hear that you're financially secure to get on with the business, because there will be obviously other founders not in quite such a good position. But let's get back to deep fabrication and talk about how you put the team together. Because I remember when we spoke, you mentioned something about meeting your key colleagues on a sort of speed dating event.
Yeah. So yeah, it was a very sort of interesting moment. So the faculty organized an event for academics to collaborate with each other, and the point of the event was to let AI experts collaborate with people who want to use AI. And I was one of the people who want to use AI. I've been interested in semiconductors. I've been interested in fabricating semiconductors, but I knew there's a lot of potential that AI can do in solving key problems in semiconductor fabrication. So it was a speed dating event for people who do AI with people who are interested in using AI. And I've met my colleague, Ben Mills, a few years ago, who was doing AI at the time for laser machining, for laser cutting, big stuff, big objects. And I told him, let's try and do some AI for nano stuff, very, very small features. And I think that's where it started, really.
So was he at the speed dating event? Because I have this picture in my mind of this large room with lots of tables, and there's sort of couples sitting there, and every so often they ring a bell and they move on until you meet someone you fall in love with. I mean, did you have to kiss a lot of frogs before you met your prince?
It was a lot of people presenting their AI background, and not exactly sitting in tables, but it wasn't a kind of introducing each other very, very quickly. Right. So I introduced my pitch within a minute. Everybody has to introduce their pitch within a minute, and that's where after these pitches, we sort of mingled and networked, and then I knew at the time, even when he was pitching, I was like, okay, this is a good guy to talk to. So and that's how we basically ended up together.
Right, so he's the AI side, you're the semi side. Yeah, that makes sense.
Lots of people,
yeah. I mean, at that time, did you have a clear idea in your mind? You said you wanted to get to semiconductors, and you wanted to apply AI, but did the idea of being able to basically predict defects, did that come to you then, or how did that come about?
No, it took some time. So we did have to go meet a few times and sort of brainstorm ideas. But we did come across lots of papers, people trying to do AIs in different areas. But I think only momentum started building after we co-supervised a PhD student together. So Ismail Al-Nab, who is another colleague who's been involved directly in the company.
And Ismail is part of your team now?
It's part of the team, yes.
Yeah.
So it's only when he started, then we started building momentum. He started proposing new ideas. Ismail started, Ben also brought a few ideas and algorithms that we could use in different problems. And I proposed how we could use these in semiconductors. And then when we started to build algorithms, something that is useful, started designing new experiments where you could use AI to develop a problem that exists maybe in the industry, in fabrication. And then we've been growing slowly with people, and now we have a good sort of momentum to try and push in different directions. We used to work with simple data sets. Now we could create a huge data sets. Lithography, one of the most critical stages in fabrication. Material etching, material deposition, material liftoff. We started creating large data sets and train neural networks on them and identify problems that we could solve with these data sets. And that was
okay, because it sounds like it was within a very organic process. It wasn't like there was a single light bulb moment where all three of you said, this is it, it's defect prediction. You were trying to apply AI. Was it even trying to apply it to different aspects of the design process or the manufacturing process, and you started to drift towards the fabrication side? Was it sort of an organic thing like that?
I would say we always wanted to work on fabrication. I was specifically interested in fabrication. I think doing maybe post-design stage where the design, what you want this design to be fabricated, and everything post-design was an interesting. Every problem we tried to sort of explore it and see where AI can find can use to sort of add value, and that's how we built it essentially. So I could provide more details, but basically we're now trying to predict defects in at nanoscale level in lithography, and we're trying to expand these tools into wide varieties of fabrication steps.
So let me just, because you alluded to the fact there were many steps in the semiconductor design and fabrication process, and you're talking about lithography. Now, for those of us who are not trained exactly on the detail, where does that fit in from, the moment the designer sits down and designs a chip to out pops a chip at the other end? Where does lithography fit into that process?
So I would say lithography is one of the most critical steps in the fabrication process because it's the step that defines the pattern or the shapes of the structures that you want to make. You start with a silicon substrate. Imagine there's a silicon substrate, and you want to put all your pattern on that substrate. But you start with a film, which is not very important, not critical to the device itself, but you pattern that film with light, ultraviolet light, through a mask. So you get light through a mask that has a pattern that you want. It's a stencil, and then that light changes the chemistry of that film, and that film will pattern essentially. And then from that film, you want to transfer that pattern from the film to the semiconductor material, the silicon itself. And then you start doing other processes like etching, material deposition, material lift-off, polishing, and so on and so forth. But the first step is lithography, and that defines the pattern that you will be transferred onto your substrate. And
that's got to be right, because if there's any faults or defects in that, then that will just filter through the rest of the manufacturing process. So what is it you're looking for in the lithography process? I mean, how is it that does the designer or whoever it is say, okay, here's the what it's called lithograph or whatever it is, here's the thing we've created? Do they just kind of notionally hand it over to you and you put it in some sort of scanner, and then your AI model kind of analyzes it? How does that process work?
Yeah, so the process of lithography has a wide number of parameters. You could think of these are different knobs that control the outcome of the process.
Right.
So we need to optimize the process, or we need to optimize the recipe that is used to get that process, right. And what I mean is get the patterns exactly how they are designed.
Right.
And so if you design, let's say, a line that has a width of 100 nanometer, and if a pattern comes up with a different number, maybe 120 or 130, that's going to change the performance of your, let's say, devices or your transistors or your photonic device. But imagine you've got billions of transistors that are connected together perfectly. These have to be perfected to a nanometer or to an angstrom precision. Getting any changes in the dimensions in any aspect will have a detrimental effect on the performance of the device overall, of the transistor overall, of the circuit, sorry, overall. So making sure that we can perfect the fabrication without too many times of doing trial and error to optimize the recipe, to optimize the fabrication process. That's the value we're trying to add into the industry. Traditionally, people used to basically do trial and error, so fabricate, do lithography, and then see the pattern, and then repeat, change the recipe a little bit, and then do the fabrication, repeat, and so on. We're trying to use AI to train it on a small set of fabrication recipes or a small set of data, and extrapolate that to sort of to predict any pattern with any fabrication recipe that you can potentially apply. So reducing that trial and error, and that essentially reduces the amount of time that you would need to improve the pattern, and also ultimately leading to less defects in the pattern.
So you can actually, it's sort of like a recursive modeling thing, so that you can go through, you get a pattern, you've analyzed it, you've realized that it's not quite what you want, so you adjust it, and then you get to the point where you say, okay, now I'm happy, let's actually fabricate this, and then you've got a much better chance then that the silicon that you produce conforms to specifications.
Yeah, so traditionally people used to spend months doing this recursive process in the lab, try and actually fabricate it and see how it works. We're trying to give them the software tools that they can simulate it and optimize the recipe without going to the lab. Before going to the lab, optimize the recipe, and then increase their chance of getting the perfect fabrication when they actually fabricate it.
So, and how long, you say it could take, they could go through a several month cycle if they were doing it through fab check, fab check. What would be the cycle, the time saving in doing it through your modeling tool? How quickly could they get to a design that they could have some confidence that if they fab it, it will be fab?
So within lithography, I think we can actually we could reach as much as 90%. So reduce the sort of time they would need by to only 10% of the time. So if it takes them 10 weeks, we could get them down to 1 week, let's say, in terms of getting that recipe right.
Well, that's a huge saving, obviously, in time and effort, and obviously in the cost of having to have done multiple fabs and
Yeah.
basically throwing the stuff away. So it sounds like that. Do you have a name for your tool, by the way, or do you just call it by the company name? It's the Deep Fab tool.
It's Deep Fabrication. I think we call it Deep Litho at the moment for lithography.
Okay.
Deep Litho, and we have also Deep Etch, Deep Deposition, and expanding that portfolio.
So
further.
these are different parts of the
Yeah.
of the manufacturing chain,
Of
but
the
lithography is the key one that you wanted to focus on to start with, and your tool is therefore basically being used by, I guess, any companies that are manufacturing chips or
Yeah,
designing chips.
that's the plan. Potentially, our customers are companies who manufacture chips. Could be anywhere from small manufacturers to really large manufacturers, and that's essentially our customer base.
How far along are you then with the model? Let's take the lithography one. Have you had a chance yet for any potential clients to try it out in real life?
Yes, we at the moment we're developing it in Southampton. We're using, for example, Cornerstone to test it.
Of course,
We're
yeah.
using smaller companies here within the UK to test it. We're going to also within Europe. We're working with critical or key sort of companies within the semiconductor supply chain to try and test it. We haven't reached the biggest manufacturers yet, but we believe this is a stepping stone. So we test at a small scale and then manufacturers within Europe, and then go internationally and test it within large foundries.
With the big guys like your TSMCs and all the other usual
Potentially, yeah.
suspects. So how do they use it in practice? Is this some sort of cloud-based model that they kind of log into, or is it something they run on premise? How does that actually work?
I think we're using a classical way of licensing software. I don't think we are going to launch it on a cloud because for security and data protection reasons, but it's going to be a normal sort of license through a software that could be installed locally within the manufacturer's high performance computers or a desktop computer, and then get that locally.
So it can even run on a desktop computer?
Once it's trained, it is trained. Yes, it can be used on a desktop computer. If it's during training, it requires a workstation or a larger computer. Because
So
training requires computational power, and that's important to get the training fast.
and the training is very specific to the manufacturer they have to train it in their own sort of processes and things. How long is that process? If someone comes to you and says, okay, Yasir, I think this is something I'd really like to try out, how long would it take them to kind of get started and start actually using it in earnest, do you think?
We're developing the software, trying to make it as simple as possible, but I think that's something we need to work on. So, let's say it's not too hard to know how to get the data ready to be used for training. Once we're talking about days, maybe the training itself could take hours, but also the more data you feed it from fabrication, the more it will become better at predicting outcomes in fabrication, better at optimizing recipes. Yeah, essentially we do it within days, and training itself could be hours or a few days, depending
And
on
it
the
learns
size
how
of
it goes. It's an iterative thing. It learns not so much from its mistakes, but it learns from the experience, and each time it gets better and better, and just carries on carries on getting better.
That's our ambition, is to give the tool to the customer and allow them to train it themselves. And the more data they feed it, the more it will become better at predicting fabrication outcome, better at predicting a wide varieties of different recipes, and that will make it much more sophisticated. And then, of course, the problem depends on the customer itself. Each customer has different patterns that they want to fabricate,
Yeah.
and if they can train it themselves, that will make them much more capable in getting the best results possible.
And so from a commercial point of view, you said it's probably going to be licensed on a traditional software model. So you've got like the lithography module, if you want to call it that, Deep Litho or whatever. Is the idea then sort of land and expand? So when you have got the next module working, assuming they use that, then they can license that and so on until they have a suite of deep fabs modules covering, I don't know if it's the entirety of the manufacturing process, but that's how you see the sort of commercial model.
That's our ambition, really, is to try and provide models for every step within the fabrication cycle. Uh, we are a small team at the moment, so we're only focusing on lithography and a bit of etching and deposition. We are trying to test it on a wide varieties of different device structures, different processes within fabrication, and test it within a wide variety of customers. As you mentioned, land and expand. Sell to a customer the lithography tool and expand into etching and deposition, commercialize these further, and then sell it to other fabs as well.
Wow, that is some ambition. I mean, in order to do that, of course, you do need to you need to have funding. You need to feed and water the troops and pay for access to the services. Talk a little about that, because I'm aware back, I can't remember exactly when it was now, you did get a research grant from Innovate UK. Can you talk us through sort of the funding side of this and where you think that you need to get to in order to, well, start reaching your ambition, I suppose?
Yes. So as an academic, we do get research funding, which is quite great. The University of Southampton is very supportive to my research group and Ben's research group in getting funding for developing all these kind of activities for manufacturing semiconductors. So we've been getting different fundings from the Engineering and Physical Sciences Research Council, the Royal Society, or Academy of Engineering, but these mainly for research. But then the companies launched when we got an Innovate UK grant. Innovate UK is specifically for companies, and that helped equity-free, sort of providing equity-free funding to do prototypes of our research and develop these prototypes with Cornerstone and local sort of fabricators within the UK.
Okay, so in order to apply for an Innovate UK grant, then you need to have a startup, you need to have a company, or you have to commit to create one if you get the dosh, so to speak. Yeah.
I think for that specific call, it didn't matter whether you had one, but once you were awarded, you had to commit to making one. So that's actually the trigger point that allowed that sort of triggered our incorporation on July 2025. Is that Innovate UK grant? So yeah, we created that, and we got the funding, which is great, and that allowed us to expand. And now we're looking to raise more funding through angel investors and venture capital.
How much are you looking for now?
So at the moment, we're looking to raise 1.2 million through the company. Half of that will be used to recruit a team of fabrication engineers, AI developers, machine learning experts, and the other half will be also to run pilot studies within companies like TSMC maybe or Intel.
Are you getting anybody to help you find the funding? Because you mentioned sort of angels and others, or are you kind of knocking on doors saying, "We've got something great here, please, sir, will you give me some money?" How's that fundraising process actually work?
Yeah, so we're lucky that we have access to Future Worlds. You mentioned Future Worlds at the beginning. It's the on-campus business accelerator. But Future Worlds has a fantastic team of mentors, and many of them are working in semiconductors, AI, And the fact that many of them also are from Southampton are helping us to sort of connect with an even larger network of VCs and angel investors. So mainly through networks and through Future World, through other sort of LinkedIn, other platforms like LinkedIn, or connecting with VCs at the university at with large fund managers and
Sure.
fund companies. So we've also been connected with Rathbones.
Oh, is that
As
okay?
yeah, so Rathbones also providing us access to a good network of investors and entrepreneurials, and it's just that's how it works in our case.
That's fantastic because you with Future Worlds is really then sort of an incubator, I guess. I mean, you had to apply one of, I don't know, 10, 100, 1,000 who applied for a cohort and you got accepted. Is that how the process?
Yes. Future World is the on-campus business accelerator, or it's an incubator.
Right.
It was funded recently by a large research grant called the Responsible AI Research Grant. It's a £30 million grant that was given to the University of Southampton to develop AI research, but also to incubate AI businesses. So it's been running for a few years now, and I applied for it as part of many companies. Selection process was that I was invited to join a boot camp after filtering companies. We joined a boot camp for 2 days. There were a lot of interviews, a lot of activities and pitches, and from that they selected. I think there were about 12 to 15 companies, which were in wide varieties of sectors, but all using different forms of AI technologies for different applications. I was probably the only one who's doing semiconductors, and that's where I graduated from. It ran for almost 9 months, 9 months to a year,
And
and
that's where I met you. It was actually at the graduation
that was
ceremony,
the
wasn't it?
graduation day. Yes,
Yeah.
at demo day.
Yeah. And when you started the program, you already had Ben on board and Ismail on board. You already were a team. And what role did Southampton University's technology transfer office sort of play in this whole sort of incubation acceleration process for you?
So the transfer office has been doing really helpful stuff in terms of patenting the technology. The technology is, because it's based at the University of Southampton, we patented that technology to provide security. They're providing us a huge support in terms of doing the spin out process, going through the spin out process, making sure that the terms and everything is as perfectly and as suitable to everybody as it could be. And they've been sort of redirecting us in terms of different raising different kind of fundings. So the University of Southampton is nominating the company to different forms of funding
Hmm.
internally and externally, and we've been actually quite good in getting funding to grow that company through the TTO office. So um, yeah. Also iCure. So iCure was at an earlier stage we joined iCure, which provides funding to
Oh, I have
um,
heard of that before.
through sort of early research, or sorry, mature research that goes into potentially startup companies, and provided me funding at the time to um, um, visit companies and speak to international customers.
Because I know I know this because I speak to so many founders and entrepreneurs. The process you're going through, particularly as a researcher going through spin out and incubation, is hugely demanding on your time from a sort of admin commercial point of view. But you are an electronic engineer at heart. How do you manage the conflict between, I guess you'd really like to get down to the micro nano stuff, and meanwhile you've got to talk to another potential investor here and you've got to do a pitch there. How do you strike that balance?
It's a learning curve, actually. I don't want to say that I've learned it yet. I'm still learning as I go. But yeah, you're right. I do wear several hats. I am the CEO of a company, but also I am running a research group. And over the time, I'm going to have to go through the company eventually. But um, uh, a lot of time management has to go through this, and maybe I'm a morning person. I like to do things in the morning. Whenever it's something that requires focusing
Yeah.
or preparing a very good pitch or thinking about a research problem or a problem that we need to develop, we to solve in the company, I have to do it in the morning, and I try to leave everything in the afternoon that is related to admin and paperwork. So I try and organize my time, but of course that can't be done just by mornings and afternoons. I have to spend lots of evenings and weekends trying to do the grind, and um, that's not easy, but it's actually quite fun. So I quite enjoy it, and I don't regret it at all.
Just as well. Wait, you mentioned you have a family. What do your family think of about this? Do they wonder where you are where you are at night? Oh, he's doing some more research again.
Yeah, I don't think I had a very entrepreneurial family.
Oh,
Parents, no, they're not. My parents were mainly just employees of. So my father was an academic, but he was an employee of a university, and nothing too dramatic. Also with my mom, so she was working in the Ministry of Health, but also employed. So it's both in the public sector. But I think they think that I told them that look, I'm making my ends meet through the property business, so you don't need to worry about me being bankrupt. So at least I could survive even if this fails. And my family's always been supportive. They always encouraging me to do things. My wife has really been supportive as well, and in this journey, and I just can't appreciate that enough.
oh, that's wonderful. But did you say you're still lecturing at the uni?
I am lecturing, yes. I'm still a full-time lecturer, academic. Until I get funding through the company, I won't be able to transition completely, but that's the plan, is to try and transition as soon as possible once the funding is raised.
So this is the 1.2 million that you're looking for. How close do you think you are you are to that? Are you getting positive responses from the investors?
Yeah, engaging with a network of investors. Some of them have already funded companies here in Southampton, and I've joined a few angel investor sort of syndicates or groups, and I've been getting good funding. Nothing been written on stone yet, but um, fingers crossed in the future.
Well, written on paper would be a good start as well.
Yeah,
But,
absolutely, yes. Written on paper.
what time frame are you hoping that you will be able to close the funding if things go the way you hope?
I'm hoping before the end of summer.
Well, great,
So,
great.
yeah,
And then, as you say, you can hire
in the
more
next
people
four
and you
months or
can
so.
do all the things you want to do. And is that the point then that you'd be able to say, well, okay, now I need to devote myself full time to this, cut back or cut out the lecturing, let the properties look after themselves, and then it's gung ho and onwards
Yeah,
and upwards.
absolutely, absolutely. That's where becomes very obvious, to a no-brainer to go full time on the company.
And you come across to me as feeling very confident that you will get that funding and that you'll be able to get to that next stage. And
Yes,
how
response has been very positive.
yeah,
Yes, yeah.
and how long a runway does that give you before you get to the point where you say, well, okay, in order to get to the next milestone, we need to raise some more funding?
Yeah, I think I'm expecting about 2 years. That should be enough to keep us going for 2 years, and we will have even bigger problems to solve at a time. So we'll probably require more funding then. But that 2 years will be mainly to recruit a few researchers, a few engineers, let's say, who tackle the critical problems that we're currently facing in lithography, and provide the key solutions for industry.
Oh, and when would you actually hope to be generating revenue from customers?
Um, I'm hoping also within 2 years. I mean, we're gonna try and commercialize, let's say, smaller versions of our models,
Yeah.
and try and generate some revenue, and that will create even more traction to customers. So, I'm hoping within the next 18 months to 2 years, we'll have potential customer who can basically pay for our models.
sort of the anchor client, so to speak, and from there, hopefully, the good word spreads and others come on board. I mean, as you look to the future and as the business expands, do you see yourself still remaining the leader in terms of the CEO and leading the business, or do you feel there'll be a point in time where you'd rather like to get back into the depths of the electronics and the semiconductors, and maybe let someone else take over, if you like, the commercial direction, the commercial leadership of the business, so that you can get back to what you really enjoy doing, or perhaps you really enjoy doing the leadership?
I do enjoy doing the leadership, but I recognize that I think there are areas where I sort of need more support with. So if somebody comes in and I find that they are in a much better position to lead it than I am, then I'm happy to take a CTO role, or if somebody's more tuned to the commercial aspect of semiconductor tools. That that would be the best fit for them. So I'm open. I'm quite flexible with that case. But I do enjoy doing the leadership role, and I am learning and developing myself through it. So we'll see what happens in the next.
I think that's a great attitude, actually, because there are some sort of technologists who that really is where they want to be, and being a CEO is just is just a pain. And others who say, no, come what may, I want to be the leader. But you see, it's let's see who's the most capable, to do the role in order to make the business successful. And I think if you go forward
Absolutely.
like that, that is really really a great place to be. Because who can tell? Who can tell in the future? And I've spoken to so many startups now, and some where the original entrepreneurs are the CEOs, and others where they've been very happy to hand over to an external. Sometimes it's a CEO, sometimes it's like an executive chairman role who has the commercial nous and the contacts, but all these things will be open to you. Just to kind of tie things up, and it's something I like to ask every entrepreneur that I speak to, and you are still very much on the journey, but you've gone through a lot from being a research scientist through to now CEO of a real live business. What is it? It's really a two-part question. What is it that you know now that you wish you would have known when you started up the whole idea of creating a startup?
I wish I've started much earlier. I think I did kind of leave it a little bit to simmer, but I think I had to leave it for some time to get a very good idea that I'm confident about. What do I wish that I've known? I'm not sure if there's a lot. I've learned so much. I think growing a team, structuring a team is something I've learned.
What's the most important thing you learned? If a young founder came, someone that's 10 years, 12 years, 15 years your junior, in the same position as you were when you started at Southampton, and said, Yasir, what's the one or two things that I need to know that you've learned that will help me on the way?
Um, I would say probably negotiate hard. Try and as much as possible to negotiate hard to make sure this because this is going to be your baby essentially. And
Yeah.
I would say there were a couple of books that I wish I've read earlier. So the Lean Startup is one of the books that I've read earlier, and also the Mom Test, which is about testing your product with customers. And I think this is something that I could have tried even earlier. It took some time to.
So that's really business oriented, commercial oriented, rather than Gates and
Yeah,
what have you.
yeah.
That kind of shows the sort of the mettle of the man. You clearly do have that in mind, and I doubt there are many entrepreneurs who would be thinking that early about the commercial and the business model side of running a business. That's most encouraging. It sounds like you're really enjoying it, and you and you're getting you're getting the results, which is absolutely brilliant. And so, very much hope that we can stay in touch, and do tell us, when you've got the funding. We'd like to be able to spread the good word, and hopefully track your progress into the future. So for now, Dr. Yasir Noori, thank you very much indeed, CEO of Deep Fabrication. Thank you for joining me on the BritChips podcast.
Thanks very much, Anthony.